The problem is that if something happens in terms of the process going down, the agent will be disrupted. So for example, let's imagine that our process is down because the server is down. Maybe there was a glitch in the network. The agent is not able to recover. And even if we restart the service, the agent is stuck. And if we try to restart, ultimately what happened was we wasted all of those LLM calls, as a result wasting time and money. And now we have to restart the entire process. By the end of this tutorial, you'll learn how to build an OpenAI deep research agent using Python. And then you'll learn how to make it durable and survive any kind of crash by adding Temporal. Here's what the agent looks like. Every single interaction here is an actual OpenAI web request. And after a few clarifying questions, the agent goes off and actually does some deep research and compiles a report. When we add Temporal underneath the hood, we're actually going to be able to have observability into our entire workflow. We will see every single action that our agent performed, from starting the research to having a triage agent to invoking a clarification agent, receiving user input throughout the deep research session, invoking the planning agent, and then afterwards invoking our search agents that go on and do the deep research, come back to us through a writer agent that compiles a report, ultimately completing the entire activity. And if we come back here to our chat interface, we will see that our research is completed and we can view the full report. We've gotten some really cute dogs back, like the Shiba Inu. I really love those kind of dogs, super cute. Ooh, the Alaskan Kleekai. Not sure if you've ever seen one of those, but they are also adorable. Anyway, let's go ahead and build this. By the way, throughout this tutorial, I welcome you to code along so that you can practice your skills. And ultimately, the final solution will be found at this open source repository that you're going to clone. And if you get stuck along the way, the answers are located right here in the documentation, which you will find in the description of the video. The very first thing that you will actually need if we're going to be working with OpenAPI's deep research is an OpenAPI key. So you can get it here at this URL. Once you have your OpenAPI key, you can store it in your zshrc profile, or you can store it in an end file that we'll set up in our repository. Next, you're going to want to go ahead and clone the repository and then navigate to this directory over here. I have already done so. You can see I've already cloned and navigated to this directory, and I've also started us on a video tutorial branch that you will be able to follow along with, committed to the repository. Let's begin with the UV sync. Create a copy of our environment variable file. If you store this in your zshrc profile, of course, you don't need to do this. But if you didn't, you'll open up this .env file over here, and you will enter your OpenAI API key over here. Next, you're going to run this command in order to spin up our deep research agent. You will see that it opens up on localhost 8234, whatever port is available on your machine. This is what the agent looks like. It's a fully working agent, uses OpenAI underneath the hood. We can start searching for something. Every single request here actually uses OpenAI in order to go and do some research. There's also a clarification agent. There is a triage agent. And then there is a writer agent that summarizes everything. While this current agent works well, the current problem with it is that if something happens in terms of the process going down, the agent will be disrupted. So for example, let's imagine that our process is down because the server is down, AWS is down, maybe there was a glitch in the network. The agent is not able to recover. And even if we restart the service, the agent is stuck. And if we try to restart, ultimately what happened was we wasted all of those LLM calls, as a result wasting time and money. And now we have to restart the entire process. We can fix that using a solution like Temporal, which I'll show you later towards the end of the video. However, I wanted to make you aware that this is a very common problem with utilizing AI agents today. Before we dive into actually making this agent durable utilizing Temporal, let's explore the setup a little bit. The UI folder contains the chat interface that you just saw me interact with. Inside of the deep research folder, you'll see several agents that are actually working together. There's a clarifying agent. This one is responsible for taking vague responses and making them more specific. There's a planner agent that takes all of the responses and creates a plan for the research. There's a search agent that uses the built-in web search tool to execute the real web searches and produces concise summaries. There's a triage agent which decides whether the responses to the queries are specific enough or there needs to be more clarification. And then finally, there is the writer agent. The writer agent synthesizes all of the search results and compiles a comprehensive report. Here's a visual of how the agent pipeline works. we have our user query that comes in. Our triage agent decides if this is specific enough. If not, it passes off to a clarifying agent, and then the user answers the questions. If it is specific enough, it goes to the planner agent that ultimately passes off the answers to the search agent. The search agent runs multiple searches concurrently, passes all the information off to the writer agent that synthesizes the result in a report, and that final report is created. Underneath the hood, to build this entire system, we are going to be using OpenAI Agents SDK. This SDK ultimately makes it significantly easier to interact with the OpenAI API, reducing the amount of code that we have to write and also the amount of maintenance that we have to do in that. And so, for example, if you want to create an agent that performs a specific function, you can do it in the following manner: giving the agent a name, instructions, and supplying the model that the agent will use. A runner executes those agents. If you'd like, you can chain together multiple agents in the following manner. In this case, agent 1 plans what to search. So this agent is the planner, and it creates a search plan. We run the planner agent, and we store the results in a variable. Agent 2 is the searcher that will search the web, and utilizing the plan's final output, we get back some search results. And agent 3 writes the search results into a report, and so we can pass in the final output from the results into our run method, ultimately creating a report. Okay, one final piece before we actually start writing some code. The OpenAI Agents SDK has a built-in integration with Temporal via the OpenAI Agents plugin. If you don't use this plugin, what's going to happen is exactly what you saw in the demo that I showed. A web request is going to be made to the OpenAI agent, and if anything goes wrong during that web request, process will be lost and you will need to restart unless you're creating your code in order to be able to remediate those situations. But using the OpenAI Agents plugin, that allows it to plug into Temporal, which ultimately creates the durability, the ability for us to retry the exact activities that we want, and our ability to replay at a specific point where the failure happened. Ultimately, Temporal allows us to code for the happy path, and all the error paths are automatically handled by Temporal. All right, enough talk. Let's add OpenAI agents to our project. Next, we're going to create the interactive research manager. In this case, this is what the research manager does. There's a user query that comes in. The triage agent asks whether this is specific or not. If it's not, the clarifying agent will ask another question. If it is specific enough, then this goes to the research pipeline, which does the plan, search, and write the report, and then ultimately returning a completed report. Let's add all of our imports, which are importing all of our agents and our models. Let's add a clarification result to know whether our agent needs more clarification or not. Let's also add an interactive research manager class, which will orchestrate the multi-agent research pipeline. As you'll notice, it's pulling in all of the agents. No special temporal code is required here. Let's also add some methods that will actually allow us to execute the steps of the entire research process. And so, for example, we can do plan searches, which will use our planner agent to run the planner agent and return a result. We can perform the searches, which will run the search agent and return a final output. And we can write the report, which will use the writer agent and return report data. And with all of those methods existing, we can now define our research pipeline that we can execute in 3 steps: planning the searches, performing the searches, and then writing the report. Next, we're adding a method that will execute whenever all of the clarifications are completed. We're calling it run with clarifications complete, and it's calling the run research pipeline method and passing in our enriched query. Next, we add a run with clarification start method. This one is the one that decides whether clarifications are needed. In this case, we execute our triage agent to check if the clarifications are needed. It checks the triage result and decides whether it needs clarification. If it does need clarification, we call the clarifying agent. The clarifying agent returns questions, and then that's returned in a clarification result. Otherwise, if there are no clarifications needed, we just run the research pipeline and return the clarification result with no clarifications required. Just to summarize here what you've built. Run with clarification start will be called when a user submits an initial query. It will triage the query, return questions, or a completed report. And then run with clarifications complete. It's called when the user answers all the questions and it enriches the query with answers and runs the full research pipeline. If you get stuck, don't hesitate to reference the code in the repository. Now we bring in Temporal. At this point, the manager is doing a great job of orchestrating the LLM calls, but there are a few things that it can't do on its own. Persist state across server restarts, wait for humans without burning resources, resume from failures without rerunning completed work, which is fine. It was never designed to do any of that. That's where the workflow comes in. The workflow wraps the manager, tracks all of the long-lived states, the original query, clarification, the user responses, and uses Temporal's primitives to wait indefinitely while waiting for human input and remaining durable. So instead of holding everything together with in-memory state and hope, we get something that can stop, restart, and pick up exactly where it left off without repeating work or losing context. Let's add a research workflow file. And what we want this workflow to do is to be able to wait for research to start via an update from the UI, determine if clarifications are needed by calling the manager, wait for human answers. Thanks to Temporal, this can wait indefinitely for as long as we desire, complete research when all answers are collected, and to return the final report. Now let's define some data classes that the workflow is going to use in order to communicate with the outside world. This is what the UI sends when starting research. This is what the UI sends when answering a question. This is what the UI polls to show progress through research status. And then this class represents the final output when research is complete. Let's define our workflow and call it interactive research workflow. Please note the annotation at the top using workflow annotation. The workflow instantiates the interactive research manager that we created. Here's a question for you to think about. Why is it that we are instantiating the interactive research manager inside of a workflow? What special capabilities do we gain as a result? Think about it. Pause the video. When you come back, I'll give you the answer. Creating the manager inside of the workflow is actually the key to making your LLM calls durable. When the workflow calls self.researchmanager.run with clarification start, this method calls runner.run internally. Because this happens inside of a workflow context, the OpenAI agents plugin intercepts those calls and executes them as durable activities. The manager itself has no temporal code. It's just plain Python. The durability comes from where it runs inside a workflow. And the plugin configuration on the worker, which we will configure in the next part. Remember our interactive research manager? No durability built in, no retry logic. This is just plain Python. And also note how there is no manual retry logic, checkpointing, or crash recovery code, just a happy path. Let's go ahead and add a helper method called buildResult that will build our result object. Now, let's look at how the UI communicates with the workflows to support human-in-the-loop interactions. This is the part that usually goes wrong. Most systems are very good at handling fast, automated work. They're much worse at handling humans who have a tendency to disappear, get distracted, or come back 3 days later after a TikTok binge. The research workflow follows a simple pattern. The workflow starts and immediately waits for the user's research query. The user submits a query and the workflow processes it. If the query needs clarification, the workflow generates questions. The workflow pauses and waits for the user's answers. The user eventually responds, and the workflow resumes and completes its research. That eventually is actually doing a lot of work. In a traditional server setup, this is where things fall apart. You either block a request, burn resources, or invent a complicated state machine that everyone is too afraid to touch. Temporal handles this differently. The workflow can pause indefinitely, hours, days, even weeks, without consuming resources. Its entire state is durably persisted, and when the input finally arrives, it resumes exactly where it left off. No polling loops, no background checking every 30 seconds, just in case, no mysterious timeouts. From the workflow perspective, waiting for a human is just another state transition. And here's how the UI, server, and workflow communicate to make all of that happen. Sending input, receiving input, and waiting throughout the process automatically by Temporal until the workflow completes. The workflow exposes 3 types of handlers for this communication. Get status, which is of a query type that's going to read the current state, questions, answers, status. Start research handler, which is an update. It will send query receive status with any clarification questions, and then provide clarification handler, which is an update that will send answer and receive updated status. Let's go ahead and implement each of these handlers. Note that we're using a workflow query, and this get status method serves two purposes. First, as a query handler, where clients can call it directly to check the workflow's current state. And second, as a helper, the update handlers, which we'll add next, call it to the return status after modifying state. An important thing to keep in mind are that queries are read-only. They can inspect workflow state, but they cannot modify it. Now let's add the update handlers. These are done through updates. Updates are great for synchronous read-write requests. If your request must be asynchronous, consider sending a signal followed by polling with a query. And as you can see, an update sends information from a client to a workflow. It can modify the state and it can return responses versus a query that cannot modify state. And then there's a third type of way to communicate, which is a signal which can modify state, but it does not return responses. You get those responses by querying the workflow. Let's add an update that starts the research. Here we're using the workflow update and defining a method called start research. This method will start a new research session. You can see we're using the workflow logger, which is the recommended approach if you're going to be logging inside of the workflow. Using our research manager, we run with clarification start and get back the result to check if clarifications are needed. If we need clarifications, then we store the clarification questions. If we don't need, then we populate the final report. Next, let's add the update that accepts clarification answers. Using a workflow update here, every time a user provides any clarifications, they are appended to our clarifications responses. Now that we've created handlers for receiving input through updates and clarifying state through queries, we can add the main run method that coordinates everything. This method is responsible for waiting on external input. First for the user's research query, then potentially for answers to the clarification questions, which means waiting on a human. This is where workflow.wait condition comes in. It does three important things. It pauses the workflow until a condition becomes true. It consumes 0 resources while waiting. No polling, no timers. It resumes instantly when an update modifies the state. If you want, you can even give it a timeout. That timeout is optional and optimistic. Now let's look at the run method itself. What's happening here is pretty straightforward. The run method starts and waits for research initialized to be true. At this point, the workflow isn't spinning, it isn't polling, it isn't holding on to a request thread, hoping someone shows up. It's just waiting. Call me by the beach. And when the UI calls start research, that update sets research initialized to true. The first wait condition wakes up and the workflow continues. If clarifications are needed, it waits for all answers to be collected. When provide clarification adds the final answer, the second wait condition wakes up, the workflow completes the research and returns the report. No background schedulers, no fragile state machines. Just a workflow that pauses patiently and resumes exactly when it should. Let's add this to our workflow. Note the workflow run here. The final step to this is to clean up the old research manager. The old research manager managed sessions in memory without durability. Now that we've created an interactive research manager, the old file is no longer needed. Here's the old research manager that couldn't maintain progress, forced the re-execution of expensive LLM calls, and if the service went down, users had to restart from the beginning. We're deleting it because our interactive research manager now supports OpenAI Agents SDK and Temporal integration. We spent a lot of time making this agent reliable. Now, let's give it something real to do. In order to do that, we need to add 2 more components. Number 1 is the worker. The worker is going to execute the workflow that has our OpenAI agents integration. And part 2 is the fast API server. The server connects the UI to the temporal workflow. Let's create the worker file. Let's add the following imports, .env, temporal.io client, common worker, and OpenAI agents. We're going to import our research workflow, load OpenAPI key from the env file, and then we're going to assign this. We're going to create a constant called a task queue that will store the string called deep research queue. I'll show you where that belongs when we actually run this. The task queue parameter is how Temporal routes work to workers. When you start a workflow on the deep research queue, task queue, only workers listening to that queue will execute it. This lets you run different types of work on different machines. Let's configure the worker with the OpenAI agents integration. Using the OpenAI Agents plugin, this is what allows us to have automatic LLM durability. This configuration of timeout and retry settings is actually one of the most valuable parts of Temporal, because this is what provides durability, it provides retriability, and many other complicated conditions that we would need to code on our own. However, here with Temporal, we can just configure them. So for example, this start to close timeout allows each LLM call 120 seconds to complete. If it takes longer, Temporal considers it failed and retries. And we strongly recommend to always set a start to close timeout. For the retry policy, this controls how failures are handled. The initial interval, it will wait for 1 second before the first retry. Maximum interval says that we will wait for no more than 30 seconds before different retries. The backoff coefficient doubles the waiting time for each failure. And so for the first one, it'll wait for a second. For the next failure, it'll wait for 2 seconds, then 4 seconds, then 8 seconds, and so on. And then the maximum attempts, it'll try up to 5 times before giving up. Now let's go ahead and connect to the Temporal client. Passing in the OpenAI plugin here into the plugins is actually what connects everything, and it tells Temporal to intercept all the runner.run calls and run them as durable activities instead. And finally, let's go ahead and create the worker and run it. The code looks like this, where we're creating a worker, passing in our client that we created above, setting our task queue, and passing in a workflow, which is our interactive research workflow that we've created previously. And then we're running our worker. Remember the template's run server file? It uses an in-memory manager, which means all the state disappears on restart. That's convenient right until you restart the server. And so we're going to update it to use Temporal instead. Come over to this file, get rid of all of the content, and start with the imports. You'll notice we're importing the Temporal client, Temporal OpenAI agents, importing our research workflow, and then we're also passing in the task queue here, should match the name of the queue that we set up inside of our worker. At this point, you might be asking, what is a Temporal client? Well, in order to interact with Temporal, running workflows, sending queries, signals, you need a Temporal client. A Temporal client provides APIs to start a workflow execution, query the state of a running workflow. For example, you can check how many clarification questions have been answered. You can send updates to running workflows, like submitting user answers to clarification questions, and you can get results from completed workflows. Each request handler needs access to the same Temporal client. To share the client across all request handlers, we create a global variable to hold the client, initialize it when the server starts, and access it from any request handler. We create a startup method, creating our global Temporal client, configuring our OpenAI Agents plugin, and then connecting to the Temporal client as you've seen before, passing in our OpenAI plugin. Let's update our API endpoint implementations. The biggest difference here is instead of interacting with the in-memory research manager, we are now interacting with Temporal workflows. So for example, with the Temporal client, we are starting the workflow here, passing in a workflow ID and a task queue. This endpoint does 2 things. The start workflow creates a new workflow execution with a unique ID. The workflow begins running and immediately waits for input. Remember the wait condition in the run method. And the second thing that it does is it sends the query via the update. The execute update calls the start research method update handler, which processes the query and returns the status. If clarifications are needed, the response includes the question. The workflow ID becomes the session ID that the UI uses for all subsequent interactions with the research session. Next, let's implement the get status endpoint. So in this point, we're gonna poll the workflow's current state so the UI can render progress, hitting API status and passing in a session ID. We're gonna get the handle to the running workflow by its ID, and we're going to query the workflow for its current status without affecting execution. We're going to compute current questions for the UI. If clarification questions are required, we increment the current question index, And then we only set current question if there are still unanswered questions. And then we return this object with session ID status, clarification questions, clarification responses, the next question to show the user, and which question number we're on. Next, we will add an endpoint to submit an answer via the session ID and the question index. Again, we're getting the workflow handle via the session ID. Using the handle, we're performing an update. This endpoint sends a clarification answer to the workflow. It gets the workflow handle, same pattern as before, using the session ID. It sends the answer via update. Execute update calls the provide clarification update handler, which appends the answer to clarification responses. And this may trigger research completion. If this was the final answer needed, the workflow's wait condition wakes up and research begins automatically. And then the final endpoint that we want to implement are getting the results, where we fetch the final research results once the workflow completes. We're getting the handle of the workflow and wait for it to finish, the same pattern as you've seen before in the other endpoints. And we block until the workflow completes and returns the final output. One important thing to notice here is the pattern that I've already mentioned, getting the workflow handle via the session ID. Once you have the handle, you can do a number of different operations. You can query the handle to read the state. You can update it to send data and get a response, or you can wait for completion via handle.result. All right, so at this point, the only thing left to do is run it and find out what I broke along the way. All right, the moment we've all been waiting for, let's go ahead and wire everything up. We're going to need 3 terminals in order to get this going. The very first thing we're going to want to do is start our temporal server using the following command. We can see that our server is now running on localhost 8233. This is what a clean temporal UI looks like with no workflows running. In a separate terminal, we're going to actually want to start the worker. The worker started, you can see on this queue. And in the third terminal, we're going to want to start the server that will run our application. And of course, as in all amazing demos, something has to go wrong. Otherwise, you know the demo is not real. We're getting this failure. Let's go ahead and fix it. All right, there it is. We finally got it up and running. We're running on localhost 8234. I'll show you what I fixed in a moment, but let's make sure that it works. So here's our deep research agent working. We can go to our temporal workflows, and we can click the refresh button here because we have one running. We'll open it up. We will see our temporal workflow executing, everything successfully, starting the search, invoking model activity triage agent. Now we're at the clarifying agent stage because our agent needs more information. It's asked a bunch of clarifying questions. Let's see what it looks like in our workflow. Here is a bunch of clarification activities. Here's providing clarification from the user. You can see everything happening here. I provided another clarification here worldwide. Final clarification provided urban. And now we pass it off to our planner agent. Here are the system instructions and what it's doing. And here it's creating a plan for best places to live. All of these search agents are running in parallel. And then we have the writer agent currently executing. You can see the attempts being recorded here, and in a moment it's going to be finished. While that goes, let me show you exactly what I fixed in the file in order to get this to work. There are a few things I missed. Number one was making sure that we actually initialize our app using the fast API server. Number two, I added this API health endpoint. And number three, I imported UVcorn and ran the application on a specific port. And then anytime that we update the code, we also need to stop the worker. So I stopped the worker here. And actually, I can even show you. You can see how our workflow finished successfully. Amazing. But here's what I'll show you. Here's the best part. We can view the full report. Everything's fantastic. Looks good. I'll review it in a moment. But actually, I can even download the markdown and review the report after. Starting a new research, that will, of course, start a new workflow. So here you can see our workflow has started and it's running. You can see the duration of how long it's been executing. When I made changes to the code here, what I can actually do is at any point, I can stop the worker. This is literally like our service going down. And even though this worker has stopped, we can come back here to the temporal UI and we can see that everything is still proceeding forward. that we are still in the same exact place where we left off. In fact, I can restart our worker, bringing our process back online, and we can continue with our deep research without repeated LLM calls, wasting time and money, and the user having to restart the entire process. Check it out here. Our workflow is still continuing almost at 2 minutes. We can see the clarifications that I provided, which is exactly what I just typed in, the cost of living in this case. Here's another clarification I provided. Worldwide needs to be safe and growing population. And this is exactly what's happening in the human in the loop, right? We're waiting for the human response. We wrote no logic. We wrote no specific logic to make that happen. It's all temporal. And let's finish it up just to get the answer. Agent is researching. We can even interrupt our agents here, shut down the worker. The searches will continue as normal. You can see that they're interrupted. That's why they're in red. In fact, you can see that here are the attempts happening. We're at attempt 2 of 5. We have 3 more remaining because we set the maximum number of attempts. We don't have to do that. We can, and it'll keep retrying until this maximum number is reached, or we can let it keep retrying forever. If we start our service back up, our process will pick up exactly where it left off. Notice the orange and green bars because now they're proceeding, but we know that they failed. Next, we're moving on to the writer agent, and that will provide us a summary. You'll note the task queue that we used over here, and up here, you'll note the workflow ID. Let's see the report. Cool. So cities like Naperville, Illinois, and Hickory, North Carolina stand out as balancing affordability with high living standards. Very cool. Yeah, all of these look great, but I wouldn't consider them safe. Yeah, I've heard of the UAE being one of the safest places to live. Apparently, you can leave your cell phone or a very expensive bag in a restaurant and nobody will ever take it. My friends, unfortunately, we've reached the end of our road. Hopefully, you are empowered now to create deep research agents using OpenAI, Temporal, and Python. You'll find the link to the repo in the description. If you have any questions, comments, or concerns, don't hesitate to drop a comment in the video. That way, I can use your input to create future tutorials. If you enjoy the content, please give it a thumbs up and subscribe to the channel. It lets me know whether I'm doing a good job. I've been Nikolai Volodkin. It's been such a pleasure. Have a beautiful day.